Today, we're diving into an exciting and intriguing news story in the realm of space and science. In early May, we witnessed a remarkable aurora that showcased the power of solar storms as they emit radiation. But sometimes, the sun does something far more destructive. These events, known as solar particle events, involve blasts of protons shooting directly from the sun's surface into space. Let's explore this fascinating topic further. These events can cause severe damage to the ozone layer and increase ultraviolet radiation levels at the surface. In a paper published on July 1st in the Proceedings of the National Academy of Sciences, we analyzed the effects of such extreme events. We also demonstrated that during times when Earth's magnetic field is weak, these events could have a dramatic impact on life across the planet. Earth's magnetic field acts as a crucial protective shield, deflecting electrically charged radiation from the sun. Normally, it functions like a gigantic bar magnet, with field lines rising from one pole, looping around, and plunging back down at the other pole, in a pattern sometimes described as an inverted grapefruit. This vertical orientation at the poles allows some ionizing cosmic radiation to penetrate as far as the upper atmosphere, creating the glow we know as the aurora. However, the magnetic field changes significantly over time. Over the past century, the North Magnetic Pole has wandered across northern Canada at a speed of around 40 kilometers per year, and the field has weakened by more than 6%. Geological records show that there have been periods lasting centuries or millennia when the geomagnetic field was very weak or even entirely absent. We can understand what would happen without Earth's magnetic field by looking at Mars, which lost its global magnetic field in the distant past and most of its atmosphere as a result. In May, shortly after the aurora, a strong solar particle event hit Mars. It disrupted the operation of the Mars Odyssey spacecraft and caused radiation levels on the Martian surface to be about 30 times higher than what you would receive during a chest X-ray. The sun's outer atmosphere constantly emits a fluctuating stream of electrons and protons known as the solar wind. However, the sun's surface also sporadically emits bursts of energy, mostly protons in solar particle events, which are often associated with solar flares. Protons are much heavier than electrons and carry more energy, so they reach lower altitudes in Earth's atmosphere, exciting gas molecules in the air. These excited molecules emit only X-rays, which are invisible to the naked eye. Hundreds of weak solar particle events occur every solar cycle, but scientists have found traces of much stronger events throughout Earth's history. Some of the most extreme were thousands of times stronger than anything recorded with modern instruments. These extreme solar particle events occur roughly every few millennia. The most recent one happened around 993 AD and was used to show that Viking buildings in Canada used timber cut in 1021 AD. Beyond their immediate effects, solar particle events can also trigger a chain of chemical reactions in the upper atmosphere that deplete ozone. Ozone absorbs harmful solar UV radiation, which can damage eyesight and DNA, and affect the climate. In our new study, we used large computer models of global atmospheric chemistry to examine the impacts of an extreme solar particle event. We found that such an event could deplete ozone levels for about a year, raising UV levels at the surface and increasing DNA damage. However, if a solar proton event arrived during a period when Earth's magnetic field was very weak, ozone damage would last 6 years, increasing UV levels by 25%, and boosting the rate of solar-induced DNA damage by up to 50%. Particle blasts from the past. How likely is this deadly combination of a weak magnetic field and extreme solar proton events? Given how often each of them occurs, it seems likely they happen together relatively often. In fact, this combination of events may explain several mysterious occurrences in Earth's past. The most recent period of a weak magnetic field, including a temporary switch in North and South poles, began 42,000 years ago and lasted about 1,000 years. Several major evolutionary events occurred around this time, such as the disappearance of the last Neanderthals in Europe and the extinctions of marsupial megafauna, including giant wombats and kangaroos in Australia. An even bigger evolutionary event has also been linked to Earth's geomagnetic field. The origin of multicellular animals at the end of the Ediacaran period, recorded in fossils in South Australia's Flinders Ranges, occurred after a 26 million year period of a weak or absent magnetic field. Similarly, the rapid evolution of diverse animal groups during the Cambrian explosion has also been related to geomagnetism and high UV levels. The simultaneous evolution of eyes and hard body shells in multiple unrelated groups has been described as the best means to both detect and avoid harmful incoming UV rays in a flight from light. We are still only starting to explore the role of solar activity and Earth's magnetic field in the history of life. Don't forget to subscribe and hit the notification bell. See you in the next video.